All right, hello, my friends. Welcome back. So, I want to show you how to create a NumPy array with random functions. Okay, so sometimes we're going to ask Python to generate random numbers, or we might just need to create an array in a particular distribution structure. And again, we're going to ask Python to develop it from scratch. For example, we will ask the distributions and statistics to produce numbers suitable for the normal distribution. Well, in cases like that, we use the random function. So I want to show you right away. Okay, so I'm running import. First, let's actually generate some random numbers. So I'll say np and call the random function. Now I'll continue and call the rand function from within this function. And this method will generate random numbers between 0 and 1. Okay, so I'm going to do Shift-Tab inside the method bracket. And see here, there's a parameter that goes up to D0, D1. So wait a minute, what's this? My friends, we can actually enter any number of values into this method with commas. So it's going to generate numbers with the size of the entered value. Yeah, so let's now enter a number into it. For example, let's say 5. Okay, and now run that. So see, it produced 5 numbers between 0 and 1. But since we only entered a single number, it produced in 1 dimension. Now, for example, let's say that we want to create 2 dimensions. Well, we're going to enter 2 numbers, right? So see, I'll just take it from here and paste it. So now, for example, I'm writing 2 commas, 3 in it, and I'm generating a 2 by 3 matrix. Okay, run it. Okay, so we've got now a 2-dimensional 2 by 3 array between 0 and 1. So I'm going to use a random function again, but this time let's produce an array suitable for normal distribution. So I'll say here np again and call the random function. Now I'll call the rand_n method from this function. So the n at the end means that the numbers to be generated will be produced in accordance with normal distribution. So you see I'll do a Shift-Tab and parentheses again. And again, just like previously, we see parameters going up to D0, D1, D2, and Dn. Now, since I mentioned these parameters in the rand method, I don't need to mention them now. So we'll consider the examples that we made in the rand function again. So I'm writing 5. Let's run it. Okay, so it produces a 1-dimensional array with 5 elements. However, these elements were produced in accordance with normal distribution. So if we want to take these values and visualize them, we'll see that these values are by the normal distribution. Yeah, so since our lesson is not about data visualization, we're just going to pass over that like it doesn't even exist. Okay, so now we're going to generate again an array of random numbers with normal distribution in the size that we want. However, we will use the random normal function, not the rand_n function. So the only difference between the two functions is the random normal function will produce arrays with normal distribution between the values that we want. See here, so I'm calling the random function from NumPy. And now I want an array with normal distribution, so I'm calling the normal method in the random function. And now we'll do Shift-Tab in parentheses. And look at that, we have the parameters, loc, scale, and size. So I'll enlarge documentation with the plus tab, and you can see what they are. Okay, so the parameters are here below. So what does it say about loc? Well, it says this is the mean of the distribution. So first we'll enter the mean. Then we have the scale. So here we're asked to enter the standard deviation of the distribution. And lastly, we will enter the size of the array. Yeah, so for example, let's say that we want to produce an array with a mean of 20 and a standard deviation of 5 with a dimension of 4 by 3. See, so I'll say 20 for the mean. All right, 5 for the standard deviation, and look at that. I open the tuple for the size and write 4 by 3. Let's run that. Okay, so look, it produces a two-dimensional array of 4 by 3. The average of the numbers here is 20, and the standard deviation is 5. Oh, and by the way, I want to tell you a little bit of something. The name of the arrays that we produce in one-dimensional form, this is a vector. And the ones that we have in the two-dimensional form are matrices. Wow. Yeah, so that's how you generate an array of random numbers with a normal method, but whose distribution we specify ourselves. Feels pretty good, doesn't it? It's pretty cool. But now I want to show you another method in these random functions. So this time, we're not going to deal with distributions, and we want to generate randomly generated data from integer values. But how are we going to do that? Yeah, we're going to use the randint method. I hear you thinking over there. This is in the random function. So we're going to use the random integer method. And I will write NP and call the random function. Now I'll call the randint method from within this function. Then I'll do Shift-Tab again. And see here, first we will enter the minor number, and then we will enter the size. So now we'll create a 4 by 4 array. So yeah, I write, let's run that. And yeah, you know what? It produces a matrix consisting of integer numbers between 0 and 10 as a two-dimensional matrix. But what do we do if you want to use these values that we created in other places? Well, we could actually put these codes into a variable, right? We could call the variable whenever we wanted and reach the array so easily. So now I'm just putting a comment mark so that these functions don't interfere. All right, so I'll come to the first one and say rand function. Then go down here and say sharp randn function. Then again, I'll go down here and say sharp random normal function. Okay, finally, I'll go down and write a sharp randint function. All right, so what do you think? That's generating arrays from scratch with the most used functions, well, that we're using in this lesson. Okay, we've been working with some of the most used parameters, and I think you're getting to know them pretty well. Now, please, go ahead and do some research on some of the other parameters, and you can learn all about them. You can also try to make the functions more specific. That way, you'll get to know these very, very well. But I'm going to call it for the day, but I'll see you next time. Thanks for hanging in there. Bye for now.